Hey, good day, stats students. I heard that you wanted to have an example of a hypothesis test. So I'm making a little video of it so you can use it. This one is actually going to be based on when we read it. It's about tree rings, and it does not give us the population standard deviation. So this one is going to be a t-test. All right. So there we go. T-test. It's going to be a t-test with data. So we want to use the data to find some information. Now, they have done something on this problem. They actually want you to use a calculator to verify that the sample mean and standard deviation are those numbers, which they are. I'm not going to do that, but that's okay. Well, we could. We'll just verify it. But let's write everything down and set up this problem. As you can see from the calculator, I actually got their values for the standard deviation and the sample mean 1268 and the 37.2886 or 37.29 rounded. Okay, so we have all of that information. Let's move forward. And so the first thing we notice is that assuming the tree dates in this excavation area follow a distribution that is approximately normal, does this information indicate that the population mean is different from either higher or lower than 1300 AD? So that's where we're going to get our null hypothesis, and here's our alpha level. So let's write the steps of the test down and put that all together. All right. Null hypothesis is going to be that the population mean is equal to 1300 AD. The alternate hypothesis is going to be that the mean is not equal to 1300. This tells us that we have a two-tail t-test. Okay. And we know that, excuse me, alpha is, my phone ring, sorry, alpha is equal to 0.01. So, since we have a two-tailed t-test, that means we're going to have a bell-shaped distribution. 0 is the mean. This is the standard t. Our degrees of freedom are going to equal 10 minus 1 or 9. So we have 9 degrees of freedom. This is a two-tailed test, so that 0.01 will get divided up into 0.005 and 0.005. And then this is 0.99. And this is the fail region. And this is the reject region. All right, if we end up in those anywhere. Okay. So what we'd like to do is we'd like to find the appropriate t value, in this case t sub alpha over 2, for this particular test. And that means we have 0.995 probability to the right of this top one up here. And so we can use that to find that t value. So t sub alpha over 2 is equal to since we know the probability, that means we want the t-value. So this would be an inverse t, and the probability would be 0.995, and the degrees of freedom would be 9. Okay, and that's what we enter on that calculator step. So I'm going to go do that. So having done that on my calculator, I got 3.25 for this t-value here, and that means the one over here is negative 3.25. All right, and now what we need to do is we need to convert our sample mean, which was 1268. We need to convert 1268 equal to x bar into a t-score, just like we would do a z-score. So into a t-score. And so how do we do that? This is where we use the formula. So the t would be equal to sample mean minus the population mean, 1,300, divided by the standard deviation, which was 37.29, divided by the square root of the sample size. And that's going to be equal to. Now, just so you know, if I enter this whole thing in my calculator, putting parentheses around the numerator and denominator really helps. All right. Other than that, I'm good. All right, so let me pause and I'll calculate this. Once we calculate it, we get negative 3.08, and that is the t-score, which we compare to the t sub alpha over 2. Now, negative 3.08 is going to be in this region right here, which is the fail to reject region. So I already know I'm going to fail to reject. But what our textbook wants us to do is to check p-value as well. So we want to find the p-value. And based on the number line, that will be from negative 3.08 to negative infinity. All right, that will be the region of the p-value right there. All right, and so that number can be found by a t-CDF, and I do negative 99,000. Let me shrink this up just a bit. Comma, negative 3.08, comma, degrees of freedom on the t-CDF. All right, let's go calculate it and check. So what we end up getting is 0.0066. Now that is only one tail, so we have to double this. All right, which takes us up to 0.013. All right, so the p-value, we multiply by 2 for 2 tails, and so that'd be 0.013. And now we can make our conclusions. All right, since 0.013 is greater than 0.01, okay, it's not a lot greater, but it is greater, then we fail to reject that the mean is mu equal to 1300. So it's likely that the dates for this archaeology exhibition, or that the tree ring dates for this exhibition match the 1300 AD date. And so there you go. All right, there's a conclusion and there's a hypothesis test. So now I want to talk about one other thing, okay? I'm only going to do this t-test as an example, but if it's a z-test, if it was a z-test, it'd be z sub alpha over 2 that you were trying to find. So right here, all right, and you would use the inverse normal to do that. And then you would enter the correct things there. Then you would find your t-score. In this case, you would find the z-score of the sample mean, and the formula is exactly the same. It would be sample mean minus population mean over the standard deviation divided by the square root of n. So that's this spot right here. And then finally, the p-value, this spot right here, instead of t-CDF, we would use norm CDF. And again, that would be to find the p-value, okay? And so if you found the p-value, then the norm CDF would give you the correct probability. And then always remember, you have to multiply that probability by 2 if it's a two-tailed test. All right? So that takes us to the proportion tests. What changes in the proportion tests? Well, if you have a proportion test, you're still going to have to find a z sub alpha over 2, because you're using the normal curve to approximate a binomial. And so that will be an inverse normal. Then you'll find the z-score of p hat, and so that will change. You'll have p prime minus the population proportion divided by the square root of PQ over N, where P is the probability of success, or excuse me, P prime, Q prime. So, and Q is the probability of failure, and then N's the size of the sample. You also, if you're given the sample proportion and the sample size, you may multiply that sample size by that sample proportion to find X. So you're going to need to know X and N as well, and that will help you to find the sample proportion and the sample proportion of failure, which is Q. All right? Once you do those two things, then this is, otherwise the proportion one is going to be the same. The p-value will be a norm CDF. And so essentially the hypothesis tests are all set up the same way. All right? So your job at this point is to do your very best on hypothesis tests. So do the problems you were assigned. I think you'll enjoy the poem ones. You have to read those closely, okay? Read closely. All right? Those are very important to do that, so you grab the information out of the poem. All right? So that's everything you need for a hypothesis test and how you do it. Good luck. I'll see you next week. Have a happy Thanksgiving. Bye.